Alright, we are looking at lesson 84 today. Your test will be Wednesday of next week. The first one on the 5th 6 weeks. We're looking at solutions of equations. Each term in a polynomial has a degree. First off, what is a polynomial?
Isn't that a term where the exponent is one thing, a number? Isn't that a variable?
More than one what? More than one term. It doesn't have any specific number. It just has to have more than one term. X squared plus 2, x to the 10th plus 5x squared plus 3, anything that has more than one term. So every term has a degree. The degree, you find it by looking at the exponent. To find the degree of the polynomial, you just find the highest degree, the highest exponent. Any questions on either of these so far? Do you understand what it's talking about? What is the degree of this term? The degree of this term? And the degree of this term? It's got to be a 0, x to the 0. Which one is the highest? No, just the exponent, 5. So what would be the degree of this polynomial? 5th degree. Does that make sense? You've probably gone over the terminology before. Okay? So see if you can figure out the degree. Don't say it out loud. Think about it. Yeah, you just you'd write 5th degree or 4th degree or 20th degree or whatever it is. Okay? Think about this one. 3, well, number 2. 3x cubed plus 2x squared plus 3 equals 0. Okay? And then looking at this one.
Oh, tricky. No.
Oh. Alright, someone want to go write the answer for the first one?
Yeah. Oh, no, you tried.
Do you agree with second degree? Yeah, the highest variable. Do you agree with third?
No.
I do not.
Why not?
Because you added 2.
There's a 1 on each of them. And since they're being multiplied together, what is the actual exponent? They're 2. Does that make sense? 1 plus 1 is 2. We're just looking at the exponents. And so what would be the degree on this one? The second degree. And then what about the last one? Y'all sure? Any questions there? Number 4? 1. There's a 1 and 0. Highest is a 1. They're not being multiplied together. Like if you have a 2 and you have a 1. Those add up to 3, right? So this would be a third degree term. Does that make sense? You add up all the little exponents in that one term. Okay? We're going to look at linear equations. You've heard that term before, right? Okay. First degree equations are called linear. Why are they called linear? They make a line. You've dealt with linear equations pretty much the entire year? It wasn't a question. But I'm glad that you realized that you have dealt with them all year. You dealt with them last year.
I don't know. The reason is because all different ways to find the slope.
Yeah, we still haven't technically gotten to the slope formula.
No!
Y'all know that y'all use the slope formula. We just haven't actually. Yeah, we haven't actually. Yeah, we haven't. Yeah, we're skipping that lesson because you all already know that formula. So.
We're skipping a lesson?
Yes. No.
No need to skip it. It's payday.
No. All right. So there are 3 possibilities whenever you have a system of equations. Do you remember these kind of problems where you solve for x and y? Well, there are 3 possibilities. You can have intersecting lines. What would that look like? Someone want to go draw it? Yeah. Somebody go draw.
I think it's yeah.
Okay. Would this work? Would that work? Are they still intersecting? Yeah. Okay. Coinciding. Okay. This one's easy, but it's hard at the same time.
I don't understand it.
Isn't it this one? I don't know what that is. Coincide.
I was trying to the same path.
They're not parallel, are they?
No parallel, but that's the next one. That's the next one. Next line. Oh, I guess you could use it. It's coincide or coincide to be basically on top of the exact same.
Oh crap.
Hey, no, don't. You've already drawn the next one.
All right. Do you agree that the 2 that are parallel means parallel?
Yeah.
Okay. Coinciding. You don't have to draw it again because it's the same line. They're right on top of each other. Does that make sense?
Yep.
Okay. So if they intersect, they're called consistent. You have to learn that term. If they coincide, they're dependent. And if they're parallel, they're inconsistent. You have to be able to know those 3 terms because it'll ask you, What are these system, or what is this system of equations? Is it consistent, dependent, or inconsistent? You have to know the difference.
Parallel, inconsistent.
Parallel, do they ever have a solution where they cross? They don't ever cross. And so if they, where they intersect, where they cross, is the solution. And so since they don't have a solution, they're inconsistent. Any questions on the terms? Do y'all understand what they look like? Okay. So you got to graph these linear equations on the same set of axes. Someone want to go graph the first one? Do you agree? Okay, someone go graph the second one. Oh, that's okay. It's hard to draw a straight line on the smartboard.
Okay. It's hard to draw a straight line. Like really, really straight.
Well, you can use a ruler on your paper. But if you try and put a ruler on the smartboard, it won't work.
Okay, here we go. Let's do it super fast.
You asked me about that.
It worked a lot better than mine.
All right. What type of system do we have?
That is
No, it's intersected.
Consistent. Why consistent?
They intersect.
Because they intersect only at one place. Looking at the slopes. Are the slopes the same? Are they different?
yes.
So it's either, well, it can't be parallel because they don't have the same slope. They can't be consistent. I mean, no, they can't be dependent because they don't have the same slope. Does that make sense? Because dependent and parallel have the same slope. Do you have to graph them to be able to do these? Yep. Okay. So looking at this one. So looking at the first one. Someone want to go graph it? Do you agree with her graph? Okay, someone want to go graph the second one?
You get it wrong side. Get it? Get it?
You had sketchers.
Had those Wyoming walls.
Can you give me some picture name?
All right, Miranda. No. Do you agree? What kind are they? Why dependent? Did we need the graph to be able to do that? If you look at this second equation, what would it be? Divide by 2? Are these the exact same? So on these, do you actually need to graph them? No. Uh-huh. The slope will be the same. The b will be different. They'll be different numbers. Looking at this one. Do we need to graph this one?
No.
No. What kind of lines are they?
Parallel.
Parallel, which is inconsistent. Any questions on why that is inconsistent? Yes, you have to know them. Looking at this one. Figure out whether it's consistent, dependent, or inconsistent. Do what? Yeah. We don't need to graph these. Okay, someone go put it into y equals mx plus b form for the first one. Do you agree?
No, I don't.
Plus 2.
All right. Someone go rewrite the second one.
One person's driving to Mall. And I went and put in Mall.
Are you jealous up here?
No.
I think he's losing.
I'm tired of saying Mall up here.
Jealous up here.
Do you agree?
Yes.
Okay. So what kind of slopes do they have?
Different.
Same slope, but are they exact same line? So not dependent. What are they? Inconsistent. Any questions on the terms? Do you understand how to do these? Do you want to waste your time graphing these? Please don't waste your time graphing them. There's,
I don't want to look at him on the TV.
I won't look at your graph, but there's no need to graph these. All you need is the equation in y equals mx plus b form. Any questions on this? Okay.